This is a tutorial on adding fractions with unlike denominators using an algorithm. So here are the steps to adding fractions with unlike denominators. First, you want to find the LCM, the least common denominator from both the fractions, and then you need to adjust the numerators by making equivalent fractions, and then you want to add the numerators, but the denominator stays the same because that's why we made it the same, and then simplify the answer if possible, and that includes changing improper fractions to mixed numbers as well as simply simplifying the fraction. So let's do some, and at any point that you want to pause and try some on your own and then check your work, go for it. So here's our first one, 1/2 plus 2/3. Step 1, find common denominator. So we look at the 2 and the 3 and we ask ourselves, what is the smallest number that they both go into? So we start with the bigger number, 3, because we know 3 goes into 3. And then we count up multiples of 3. So 3, 6, 9, 12. And we stop when we get to a number that is also a multiple of 2, or that 2 can go into evenly. So let's do that. So we go 3. Can 2 go into 3 evenly? No. 3 is not a multiple of 2. So we bump up it to the next multiple of 3. 6. Is 6 a multiple of 2? Yes, it is. So we stop. And we put 6 as our least common denominator. Now, the next step is to adjust our numerators. Remember, whatever we do to the bottom, we do to the top. So we want to make this fraction equivalent to this fraction. And so 2 times what? Let me get a different color here. So 2 times what is 6? 2 times 3 is 6. Let me get a darker color than that. And so 2 times, oh goodness sakes. Sorry about that, let's just fix that. Okay, 2 times 3 is 6. So whatever we do to the bottom, we do to the top. 1 times 3 is 3, and there's our new numerator. 3 times what is 6? 3 times 2 is 6, because now we're working with these two fractions. And then 2 times 2 is 4. And now we have our new numerators. So now here's our math problem. 3, 6 plus 4, 6. So now we add the numerators, 7. The denominator stays the same. And now we need to simplify, because this is improper, because 7 is more than 6. Makes it an improper fraction when the numerator is larger than the denominator. So how many times can 6 go into 7? It can go in 1 time. Our denominator stays the same. We have 1 left over. 1 and 1/6, and 1/6 is already in simplest form. So we are done with that one. Let's try another one. 1/4 plus 2/5. Okay, step 1, find a common denominator of 4 and 5. So let's start with a 5. 5 is not a multiple of 4, so let's go up to 10. 10 is not a multiple of 4. Let's go up to 15. We're counting by 5s, doing multiples of 5s. 15 is not a multiple of 4. Go up to 20. 20 is a multiple of 4, so we stop and we put down 20. All right, now new numerators. 4 times 5 is 20, so 1 times 5 is 5. 5 times 4 is 20, so 2 times 4 is 8. Now we have our new numerators, so 1/4 is equivalent to 5 over 20, and 2/5 is equivalent to 8 over 20. We just wrote them in different numbers so that we could have common numerators. So now we add our common denominators. So we add our numerators and we get 13. 8 plus 5 is 13. Our denominator stays the same. Now we don't have an improper fraction, but is there any number that you can think of that's a factor of both 13 and 20? Nope. So this answer is already in simplest form. If you'd like to pause and try this one on your own and then unpause and check your work, you may. All right, 3/5 plus 1/3. We need to find a common denominator of 5 and 3. We start with the biggest number, 5, the greatest number, 5. 5 is not a multiple of 3, so we have to now go up to 10. 10 is not a multiple of 3, so we go up to 15. 15 is a multiple of 3, so we write down 15. Now, 5 times what is 15? 5 times 3, so whatever we do to the bottom, we do to the top, we get 9. 3 times what is 15? 3 times 5, times the top by 5, we get 5. Now we add our numerators. Denominator stays the same. It is not improper, and it is in simplest form, so you're done. All right, here comes another one. All right, common denominator of 7 and 3. We start with 7. 7 is not a multiple of 3, so we bump it up to 14. 14 is not a multiple of 3, so we bump it up to 15. Sorry, we bump it up to 21. 21 is a multiple of 3, so 21 becomes our denominator. 7 times what is 21? 7 times 3, whatever you do to the bottom, you do to the top. 3 times what is 21? 3 times 7, whatever you do to the bottom, you do to the top, we get 14. All right, now we can add our numerators. 14 plus 9 is 23. Our denominator is 21, and this is improper because 23 is greater than 21. Well, 21 goes into 23 one time. Denominator stays the same. We've used up 21 of our 23s, so we have 2 left. Then we ask ourselves, is there any number that goes into 2 and 21? Any number that is a factor of 2 and 21? And there is not. So we're done with that one. Okay, I'm going to do one more. 1/3 plus 5/9. Now, if you notice on all the other ones, 7 times 3 is 21, 5 times 3 is 15, 4 times 5 is 20. So you might think, well, can't I just multiply the denominators to get the least common denominator? Nope, that is not always the case. Sometimes it's the case, but it is not always the case. So I will show you in this example. We start with the largest number. Let's start with 9. And is 9 a multiple of 3? Yes, it is. So if the smaller denominator can go into the larger denominator, let me put it this way, if the larger denominator is a multiple of both of them, then that just becomes your common denominator, because 9 is a multiple of 9, and 9 is also a multiple of 3. So it wouldn't be 27. If you did 27, that would be fine, but you'd have a lot more simplifying to do at the end. So now we are going to find our new numerators. So 3 times what is 9? 3 times 3. Whatever we do to the bottom, we do to the top. We have our new numerator for this equivalent fraction. And then if we don't change the numerator, our denominator stays the same. It needs to look just like the other one, because 9 times 1 is 9, and then whatever we do to the bottom, we do to the top. And now I can add. 3 plus 5 is 8. It is not improper, and it is already in simplest form. So that is a quick tutorial on how to find common denominators, but also how to add fractions with unlike denominators.